Okay, today we're going to look at z-scores, and what a z-score is, it's basically just a name for what the standard deviation number is. So on a particular question, if we were doing, say, math marks, and we said our average was 72%, and we had a standard deviation of 6, that means our lines would go up by 6 and down by 6, and so on. So we'd keep going all the way down. But what happens if we change the question, and now instead of dealing with math marks, we're looking at the height of people or the price of objects or something like that. So as the context of the question changes, you're going to have to redo these numbers each time. So what we do with a z-score is we keep our numbers sort of standard so that it'll refer to this graph for any situation. So what we do is we call our z-score numbers, where the mean is, our z-score would be 0. Where one standard deviation is, our z-score is 1. And then we continue 2, 3, -1, -2, and -3. So that means if we have a z-score of 0.4, we're actually located somewhere about there on the graph. If we have a z-score of 1.7, it'll be about there, and so on. So anytime we're doing z-scores, really what we're looking for is what location on the normal curve graph are we doing. Yesterday, when we were looking at the normal curve, we could only do between whole number standard deviations. We could figure out areas above 1 or below 2 or -2, in between -2 and 1, those kind of things. Now what we're going to do is we're going to use z-scores to find the area at any location. So the first thing we have is a formula, and the formula for z-scores to calculate them is x minus the mean divided by the standard deviation, where x is just the number that we're talking about. So let's do an example. Let's suppose you got a 78 on a test, and well, that'll be your x, so that's your mark or whatever you're looking for. Let's suppose the mean is, let me clean this up a little bit. So let's suppose your mark was 78%. Let's suppose the mean was 72% and the standard deviation was 4. So we can calculate the z-score. So on your calculator, you'd go 78 minus 72 divided by 4, and that'll give us 1.5. So what that would mean is if you got 78% on the test, compared to everybody else in the group, you are at 1.5. So you're right at this higher portion of the graph. Okay. We can also use this formula to work backwards. So let's suppose if I said you have a z-score of -1.2, and let's suppose the mean is 40 and the standard deviation is 3. The question is, what would your mark actually be, or what would the x number be? So we can use the same formula. The only thing is we're solving it for x. You'd have 1.2 would equal x minus 40 divided by 3. And then we just solve it for x. So we'd multiply by 3 on both sides first. So times it by 3. So -1.2 times 3 would be -3.6. And then we'd have x minus 40. Add 40 to both sides would be your last step. So we would get x equals 26.4. Okay, so you can use this formula. The key is use the formula anytime you need to calculate a z-score, or if they give you this z-score and they want you to actually figure out what the actual starting number would be in either case. Okay, so now our next topic is how do we get the percentages? So on our graph, we will... Okay, so now the next thing is, like I said, we're going to try to figure out what the percentage would be for any location. So if we did a z-score of 0, we wanted to know what percentage was below that. We got 50%, right? So if z equals 0, the area below was 50%. And we also did, if we had a z-score of, let's suppose, +1, and we wanted to know the area above, we know that the below part is 50%, plus 34 would be 84, so that means we'd have 16% above. So when they're on the exact numbers, we can use the chart and just basically add up our percentages, right? We could add up all these numbers if we're looking for certain areas. So what happens now is we can actually do this for any location. It doesn't have to be whole numbers, so we can do decimals and things like that. And what we have to do is we just have to use our calculator to help us figure out those answers. So let's do an example where I say find the area between a z-score of negative 1.2 and positive 0.6. So on our graph, what we're looking for, 1.2 would be right about there, 0.6 would be right about there. So we're looking for sort of area in that shape there. So we're looking, it's probably going to be 50, 60%, something like that. But we can't figure out exactly based on the graph, so we're going to have to do something different. So on your TI calculator, what we do is we can actually figure these out fairly easily. So what you need to do is, when you open up your calculator, you go to second distribution, and we choose normal for normal curve, and we do CDF. Okay, so when you pick that one, what it does is it's going to give you, if the older calculators will just type in normal CDF, and then what we do is we want to use normal CDF and we put in our low z-score first, and then we put in the high z-score second, and just hit enter. So if we do this on our calculator, we put in negative 1.2 for our low one, 0.6 for our upper one, and hit enter. If you have a newer calculator, it gives you some extra stuff. So what you want to do is just delete the zeros and the ones that are in there. You just want the negative 1.2, comma 0.6. The comma button is right above 7 if you're looking for that. Hit enter, and it gives us an answer of, okay, so for this one, if we do normal CDF, negative 1.2, comma 0.6, we put that in our calculator, we get an answer of 0.61. So what that means is we would have 61% of the data in between that range. Okay, so let's suppose if this was, this was test marks, and I wanted to know, okay, so 61% of our class is going to be in that range. Let's suppose there was 25 people in the class. So if I wanted to know how many people that represents, we just times it by the number of people. So we would go the 0.61 times 25, and that would tell us roughly 15 people. So 15 out of the 25 people would equal the 61% of the data. Okay, let's look at a different one. So let me clear this off. Okay, so now this time let's find the area below a z-score of 1.1. Okay, so we know 1.1 on our graph is right about there, so we want that entire area. So it should be a little bit bigger than 84%, maybe 85 to 90, somewhere in there. So on our calculator, we want to do normal CDF, and we want to put from low to high. So our high number is 1.1. The question is, what number do we put as our low? So we're going up to 1.1. We want the entire part of the graph. So there's negative 3. So negative 4 would be about there. So we just got to go past it a ways. So usually negative 5 is a good one to choose because it'll cover every possible low end number. So we would go on our calculator. We would do normal CDF and put in from negative 5, sorry, we want to go all the way to the bottom, so negative 5, comma 1.1, hit enter, and it gives us 86%. So 0.86 or 86%. Okay, and then once again, if we wanted to know that for 50 people, just times it by 50. Okay, so the same thing works as well. So let's suppose I want to do the area above a z-score of 2.2. 2.01. So it doesn't matter. Actually, let's change that. 2.01 is kind of a weird number. Let's do 2.11. So it doesn't matter what the decimal is. We can always use normal CDF. So in this case, we want normal CDF. And we're going to go from 2.11, which is way over here. And we want everything bigger. So in this case, let's go up to positive 5 as our maximum number. So if we go normal CDF, on your calculator, if you're doing a bunch of these, just hit second enter and it'll copy your old answer, so it makes it a little bit faster to type these in. So 2.11 comma 5, hit enter, and in this case we get an area of 0.017. So remember, as a percent, we move our decimal over 2 places, that's 1.7%. Okay, so it's going to be pretty small for that area above, which looks about right because we only have about 1% in this little area there, so that's good. Okay, so any of these kind of questions to do left, right, above, in between, and so on, pretty straightforward. Okay, the next thing we'll do is the reverse. So this time now, if I say the area is 40% below, what is the z-score? So we're just doing the reverse. So this time I'm giving you the area, and now I'm looking for the z-score. So we know the bottom portion is 40%, so we know it's going to be somewhere in there. So our z-score should be something like negative 0.5 or somewhere in that range. So what we need to do is basically use our calculator to work backwards. So on your calculator, when you do these ones, you use inverse norm. So go to second distribution once again and pick inverse norm, which is number 3. Okay, so go down to inverse norm, and in this case, all we do is put in that area. So we do an area of 0.4, and if you have a newer calculator, just delete those zeros and ones once again. Just do the 0.4, hit enter, and it gives us a z-score of, okay, so inverse norm 0.4. And we get an answer of negative 0.25, which looks about right. I guessed at about a half. I guess it would have been negative a half, but we're actually even closer to the mean. So it's only negative a quarter would be our z-score. So remember, this will give us what the z-score location is. So the inverse norm feature will give you the areas below. It'll always give you the areas to the left or to the low side. So if we put in inverse norm of 0.9, what that's going to do is it'll give us 90% of the graph to the left, which will be pretty high z-score. So we get a z-score of 1.28, so that means right about there. So we have 90% of our graph is below that 1.28 line. Okay, so that's good, but what happens now if I said, what's the z-score to be in the top 10? Okay, so sometimes if you're in a class and you want to be in the top 10% of the class, you want to figure out what your z-score would be for that. So in this case, the top 10% is the exact same thing as the 90% below, right? If we have 10% here, that means we have 90% below. So the inverse norm 90 would be the exact same thing as figuring out the top 10. We're still looking for where is that line to cut these two areas in half. So anytime it's looking for to the right or the top portion of the graph, we still do the same thing. We got to put in inverse norm, but we don't want the top part. We always want the less than part or the below part. So we still put in 0.9, because if we have the top 10%, that means we have 90% below. We still would use the 0.9, and we get 1.28. Okay, so just be careful with any of those when you're doing the top portion or to the right. You got to subtract it from 100% before you do your calculations. And that's all for z-scores.